In this video, we will discuss basic concepts of probability. Probability plays a central role in the statistical method of hypothesis testing, which we'll discuss in Chapter 8. Statisticians make decisions using data by rejecting explanations, such as chance, based on very low probabilities. Researchers have made the claim we have developed a gender selection method that greatly increases the likelihood of a baby being a girl. The hypothesis used when testing this claim is the method of gender selection has no effect, so that for couples using this method, about 50% of the births result in girls. In two tests of 100 couples using the gender selection method, one test resulted in 75 girls and the other in 55 girls. The respective probabilities of this occurring are 0.000003, or 3 10 millionths, and 0.8184, 184 thousandths. While both 75 and 55 girls are greater than the 50 girls expected, only the event of 75 girls leads us to believe that the gender selection method is effective. An event is any collection of results or outcomes of a procedure. A simple event is an outcome or an event that cannot be further broken down into simpler components. The sample space for a procedure consists of all possible simple events. That is, the sample space consists of all outcomes that cannot be broken down any further. In this example, we used B to denote a baby boy and G to denote a baby girl. For a single birth, the sample space is BG. You can have a boy or you can have a girl. For 3 births, the sample space is BBB, BBG, BGB, BGG, GBB, GBG, GGB, GGG. With 1 birth, the result of 1 girl is a simple event, and the result of 1 boy is another simple event. They cannot be broken down any further into simpler events. With 3 births, the result of 2 girls followed by a boy, denoted GGB, is a simple event. With 3 births, the result of 2 girls and a boy is not a simple event, because there are 3 possible ways that this can occur: GGB, GBG, or BGG. Notation for probabilities. P denotes a probability, A, B, and C denote specific events, and P of A denotes the probability of event A occurring. The relative frequency approximation of probability. Conduct or observe a procedure and count the number of times that event A occurs. P of A is then approximated as follows. P of A equals the number of times A occurred divided by the number of times the procedure was repeated. Relative frequency approximation is also known as empirical or experimental probability. Classical approach to probability, which requires equally likely outcomes. If a procedure has n different simple events that are equally likely, and if event A can occur in s different ways, then the probability of A equals the number of ways A occurs divided by the number of different simple events, which is equal to 1 over n. When using the classical approach, always confirm that the outcomes are equally likely. For subjective probabilities, P of A, the probability of event A, is estimated by using knowledge of the relevant circumstances. Simulations. Sometimes one of the preceding 3 approaches can't be used. A simulation of a procedure is a process that behaves in the same ways as the procedure itself so that similar results are produced. Probabilities can sometimes be found by using a simulation. There is no single universal rounding rule for probabilities, but this will apply to most problems in the book and MyLabs. When expressing the value of a probability, either give the exact fraction or decimal or round off final decimal results to 3 significant digits. All digits in a number are significant except for the zeros that are included for proper placement of the decimal point. The probability of 0.4450323339 has 10 significant digits and can be rounded to 3 significant digits as 0.445. The probability of 1/3 can be left as a fraction or rounded to 0.333. The probability of 2/8 can be expressed as 1/4 or 0.25. Because 0.25 is exact, there is no need to express it with 3 significant digits as 0.250. Mathematically, a probability of 0.25 is equivalent to 25%, but we prefer to stick to fractions and decimals and not use percentages. Professional journals express probabilities as decimals, not as percentages. When we start to use probability values generated from statistical software, they will always be in the form of decimals. When finding probabilities with the relative frequency approach, we obtain an approximation instead of an exact value. As the total number of observations increases, the corresponding approximations tend to get closer to the actual probability. This property is commonly called the law of large numbers. The law of large numbers. As a procedure is repeated over and over, the relative frequency probability of an event tends to approach the actual probability. The law of large numbers tells us that relative frequency approximations tend to get better with more observations. This law reflects a simple notion supported by common sense. A probability estimate based on only a few trials can be off by a substantial amount, but with a very large number of trials, the estimate tends to be much more accurate. Caution. The law of large numbers applies to behavior over a large number of trials and does not apply to any one individual outcome. Gamblers sometimes foolishly lose large sums of money by incorrectly thinking that a string of losses increases the chances of a win on the next bet, or that a string of wins is likely to continue. This is known as the gambler's fallacy. Second, if we know nothing about the likelihood of different possible outcomes, we should not assume that they are equally likely. For example, we should not think that the probability of passing the next statistics test is 1/2 or 0.5, since we either pass the test or do not. The actual probability depends on factors such as the amount of preparation and the difficulty of the test.